Do you remember? It's chapter 12, right? Nicholas, you still there? Nicholas? I lose your audio? Unmute your microphone. All right.
Yeah, chapter 8, sorry.
Chapter 8?
Yeah.
Okay, which part?
3.3.
Just the first one?
8.3, 8.3.
And 8169?
Yeah.
Okay, this is different stuff. So how do I figure the X-intercepts?
You put everything equal to 0.
Yeah, in other words, the X-intercepts come when y is equal to 0, or p of x in this case. So I'm just going to write this. That's my equation I got to solve. Whatever values of x make this thing true are my X-intercepts. So what are they?
0, 3, negative 1.
Now, I'm looking at a quartic. That's going to be x, that's going to be x squared, that's going to be x. If I were to multiply all three of these together, I would have a quartic, not a cubic, but a quartic. And I would expect 4 solutions. How come it appears I only have 3?
Because x minus 3 and squared is the same as x minus 3
So
times
that has multiplicity of 2. These each have multiplicity of 1. And the sum of your multiplicities will equal the degree of your polynomial. So you always will have 4 solutions to a quartic. It's just that 2 of them might be the same, as in this case here. Okay. If it has no real roots, what does that mean?
It doesn't touch the x.
Yeah, exactly. It never crosses the x-axis. Okay? If it's a 4th degree polynomial, what's the most number of extrema it can have? In other words, can it look like this? This has 1, 2, 3, 4, 5 local extrema. A 4th degree polynomial can have at most 3. Just like a 2nd degree polynomial, a quadratic has 1 and 1 only, right? In other words, all quadratics are parabolas. They look like that. There's only 1 extrema. In other words, you always have, or the most extrema you can have is 1 less than the degree of polynomial. Since this is a 4th degree polynomial, I can have 3 little bumps in it. So there's my 3. There's 1, there's 2, there's 3. I do not cross the x-axis, so there's the answer. There is a graph that has no real roots, and it looks like it could be a 4th degree polynomial. Now, 4th degree polynomials don't have to have 2 humps. Notice if I have a 3rd degree polynomial, y equals x cubed is a 3rd degree polynomial. That doesn't have any humps at all. Looks like that. But the moment I move it off the origin, in other words, if I shift that thing left or right by doing something like adding an x squared plus an x, well, now it's going to have some bumps in it. That's a that's a relative extrema, that's a relative. When I say the words relative extrema, you know what I'm talking about, right?
Yeah.
What?
Yeah.
Yeah, you may not have actually been taught it yet, but that's what I mean, is an extrema merely means, is there a point on the graph where to the left and to the right it's less, or to the left and the right is a greater? If it is, then that's a local extrema. Use the solutions of the corresponding quadratic to write each of the following expressions as the product of two linear factors. Okay, how about the first one? Guess what? It doesn't have to be difference of perfect squares. It only has to be difference of squares. They've always lied to you. I'm teasing. But they do start off by calling it difference of perfect squares because they only want you to apply it to perfect numbers, but it doesn't have to be a perfect square. That's going to factor into x minus root 10 times x plus root 10. In other words, it factors exactly as if it were the difference of perfect squares. That's a linear factor. That's a linear factor. I've turned it into the product of two linear factors. About this one.
X. Doesn't factor.
Okay, so we can solve it. We can still turn it into the product of two linear factors. What's x equal to?
The b, or negative b plus or minus.
Okay, so give me the numbers. I trust that you got the quadratic memorized.
3 plus or minus the square root of 9 minus 4 times 1 times negative 7 all over 2.
Okay, what is that? That's 4 plus 28, 9 plus 28, so that's 37. So x equals 3 plus or minus the square root of 37 all over 2. Now, how do I turn this thing into what they want? The product of two linear factors. What would my linear factors be?
3 plus the square root of 37 divided by 2.
Yeah.
Times
right.
Minus.
In other words, and it's just to be careful here, use parentheses. That's one factor. The other factor is x minus the other answer, which is 3 minus root 37 all over 2. Again, I need double parentheses. So that's the answer. Well, now it's not quite the answer. This is not the answer that they would give you. I can remove the inside parentheses. Okay? So when I remove the inside parentheses, it gives me x minus 3 minus 3 over 2 minus root 37 over 2. So I could write it like that. And this one over here becomes x minus 3 plus root 37 all over 2 if you want. I don't necessarily need that second 2 there. Okay? In other words, it's just like if I told you that the 0 was at x equals 3, you would immediately know the factor is x minus 3, right?
Mm-hmm.
Well, it's the same thing. Even if you have to use the quadratic to solve it, your answer is x minus one solution times x minus the other solution. Okay. Now, this one over here. And kind of what we did here, let me go back a step here. What we really are doing is making that equal to 0. So I ended up with x squared equals 10, end up x equals plus or minus the square root of 10. So you have x minus the square root of 10 times x plus the square root of 10. In other words, I didn't necessarily have to treat it as difference of squares. Just easier that way. But the way I'm going to solve all of these is by setting them equal to 0 and then solve it the way you normally would. So number C, let's do that. Hold on a second. Let me scroll down a little bit, give myself some writing room. So let that equal to 0, and now solve for x.
X plus 2x minus 3.
No, this is
X squared equals
the
negative.
sum. This is the sum of squares. That does not factor. What are my solutions?
X equals the square root of negative 4.
Actually, it's plus or minus the square root of negative 4, right? Because the first step is I get x squared equals minus 4. Take the square root of both sides. Whenever you take the square root of both sides, start your answer with the words plus or minus. So now x is equal to plus or minus, what's that? Here's the way to do it. There's a real simple way of doing these so that you're never confused. Always separate it into the positive and the negative number. Well, we know what that is. That's 2. That's I. So it's plus or minus 2i. So what are my factors?
X minus 2i and x plus 2i.
And I get that merely by x minus the top one, x minus the bottom one. And it gives me those two. Same thing we're going to do over here. That's clearly not going to be factorable. Otherwise it wouldn't be on this page. None of these were factorable. So, what do I do?
2 or x equals the quadratic formula. 2 plus or minus the square root of 4 minus 4 times 1 times 2 over 2.
Simplify that.
X equals 2 plus or minus the square root of negative 8.
Not -8. I think it's -4, isn't it?
Or, yeah, -4.
Now simplify that.
X equals 1.
I would simplify that first. It's too easy to make a mistake.
2i. Oh.
So what's x equal to?
Plus or minus I.
No, it's actually 1 plus or minus I. In other words, you can now divide top and bottom by 2, but these 2's don't cancel. They become 1's. In other words, that becomes a 1, that becomes a 1, and that becomes a 1. So my answer is 1 plus or minus I. Now, what are my two products? What are my two linear factors?
X plus I, x minus, or x plus 1 plus I.
Hold on. It's always x minus.
Hmm.
In other words, it's always x minus whatever your solution was. So there's one. Here's the other. And then that one, when I remove the parentheses, becomes x minus 1 minus I. This one becomes x minus 1 plus I. So those are the two factors that, when multiplied together, give you this quadratic. What determines whether quadratics, these are all quadratics, every one of them. What determines what kind of roots it has?
If it's
Called the discriminant. What is the discriminant?
I don't know.
It's the b squared. Hold on. Sorry. It's what's inside the radical is the discriminant. In other words, b squared minus 4ac. Not with the radical, just all by itself, that's called the discriminant. And it's got its own name because if this thing's positive, we've got real roots. If it's negative, we got complex roots. And if it's exactly 0, we got exactly one real root. So the only thing we have to do to answer these 6 questions is to figure out the discriminant on each one. So what's the discriminant on this one? First of all, what's b? Yep.
0.
Okay. So what's minus 4ac? Is it positive or negative?
Positive.
So that's got 2 real. That's all we need to know. We didn't solve it. We just figured out the discriminant. How about this?
Well, it's negative.
So that's got 2 complex. 2 real. 2 complex. How about C?
Positive. Or no, negative.
It's negative, right?
Yeah.
2 complex. How about D?
Positive.
2 real. How about E?
Well,
This one's a little different. In other words, they don't give us as a polynomial. They give it to us as a quadratic in vertex format. Well, remember what we learned. Where's the vertex on this thing?
0.
No, at E, a number E. It's in vertex format. It's in x minus h minus squared minus k, where h Okay, so 3, -4, right? That's right there. Should it open up or down?
Up.
How many roots does it have? Are they real or complex?
2.
2 real. In other words, I can tell by the fact that that's got to go through the x-axis because it opens up, that it's got to have 2 real roots, because 2 complex roots don't go through the x-axis. In other words, if I had a parabola that looked like this, that's going to have complex roots, 2 of them. What would this look like? What's the discriminant going to be if I've got a graph that looks like this? 0, exactly 0. I'm not doing F, just talking about graphs. In other words, because it kisses the x-axis in one spot only, it only has 1 real root. And that happens only when the discriminant is 0. There's 3 possibilities: positive, negative, or 0. And they each mean something different. So F, let's do F the same way we did E. Where's the vertex?
3, 4.
Open up or down?
Up.
What kind of solutions does it have?
Complex.
2 complex. Complex solutions always come in pairs. You never get 1 complex solution only. How are you going to prove that that's a solution?
Put it in.
Yeah. So we've got -2 in parentheses to the 4th, -4 times -2. And here's where you just want to, the first step is always just plug it in, use parentheses properly, and then simplify. Now, what's -2 to the 4th? Read the next line to me.
16 plus 8 equals 32 minus 40.
And they do not. It's not a solution. That's all you have to do to show that it's not a solution. But let's see, we want to go to what comes next. We're the last. Oh, no, there's more problems here. I didn't see that it scrolled down. This problem is a checkpoint for solving complicated equations. You know, these aren't that complicated. Solve this one here. Step by step.
Subtract 7.
So I got 2 times the absolute value equals 4. Next step.
Divide by 2.
So now I get this. Next step.
X minus 3 equals plus or minus 2.
I do it like that because I know I'm going to have 2 solutions. So x equals 5 or x equals 1. And if you plug that back in, check your solutions. Does 5 work?
Yeah.
Does 1 work?
Yep.
Number 2.
You take the square root of both sides.
Yeah. You really, before you take the square root when you're solving an equation, you'd rather isolate that. Because then after you take the square root, you're just going to be left with whatever's in that parentheses. Right now, I've got this 4 over here. That 4 is not being squared. So even though 4 is a nice number to take the square root of, and I could do that, it's not the best way to do this problem. Best next step is to divide by 4. So you end up with x minus 2 squared equals 4. Next line.
X minus 2 equals plus or minus 2.
Which makes x equal
4 and 0.
Mm-hmm. Okay, number C, first step.
So plus or add 2.
Now, when you have a radical sign in an equation, the goal is to isolate it. Well, this one's already isolated. Now what's the next thing I'm going to do to get rid of the radical sign?
Square both sides.
What's the next line?
X plus 18 equals x minus 2 squared.
Go ahead, square that. Tell me what to write, because we're going to be able to simplify a lot of this.
X squared minus 4x plus 4.
Now, if we put everything on the same side, we're going to have x squared minus 5x minus 14. That does factor into what?
X minus 7x plus 2.
Solve.
X equals 7 and negative 2.
Now, whenever you have absolute value signs, radical signs, there is a high likelihood of having an extraneous solution that does not work. Does this one, does 7 work?
Yeah.
Does minus 2 work?
Yep.
Does minus 2 work?
Yeah.
Does minus 2 work?
It does.
Left side becomes 4. The right side becomes minus 4. So no, minus 2 does not work. Cross that off. That's not one of the solutions. It's only x equals 7. Okay? Here's the things you got to always look for when you're looking for extraneous solutions. Those, and that. If you have any of those in an equation, always check both answers, because I would say that 80% of the time, one of the answers will be extraneous. And only one of these did not have those things. All right, how do I solve D? Give me the 2 equations that I can write.
2x plus 5 equals 3x plus 1. And 2x plus 5.
Or what?
2x plus 5 equals negative 3x plus 1.
It's negative 3x minus 4. In other words, the second equation, the whole right side's got to be a negative sign. So it's equal, and I put the negative sign and then put parentheses around the 3x plus 4, and that parentheses causes it minus 3x minus 4. So that's the other half, is this. And then you'll solve each one of them vertically. Yeah, let's solve them both. Let's see. That's x equals 1. And what is this? This is 5x equals minus 9. X equals minus 9/5. Well, let's check 1. Does 1 work? Is the absolute value of 7 equal to 7? Yes. Let's check 9/5. Minus 9/5. Is this a true statement?
No.
Yeah, let's see. Was that a guess or did you do the math?
Just a guess.
I thought so. You did it too quick. I can't do it this quick. Now, let's see. That's minus 18/5 plus 25/5. So that's 7/5. So it's the absolute value of 7/5. Is that, in fact, equal to minus 27/5 plus 20/5? And the answer is no. Because the absolute value of 7/5 is 7/5, not minus 7/5. So this answer is extraneous. And naturally, they made the one extraneous that was the hardest math to check. You notice that? In other words, checking the 1 was a piece of cake. Took me about 3 seconds. But checking the minus 9/5 answer took a lot of arithmetic. You can't just assume that it's not correct because it's a minus answer. P of 5. How do I get it?
You put 5 incorrect.
Okay. So it's 5 cubed minus 3 times 5 squared minus 7 times 5 plus 9. Whatever that number is. We don't need to spend time doing arithmetic. Verify the remainder theorem. What's the remainder theorem say?
That
If 5 is a 0 for this polynomial, then when I divide that polynomial by x minus 5, I will get a remainder of 0. Have to. Or if I just do this calculation and I get 0, it means that 5 is a 0. What do I get when I do this calculation? 125 minus 75 minus 35 plus 9. No. Close, but it's 4. So P of 5 equals 4. That means 5's not a 0. If p of 5 came out to be 0, then 5 would be one of my zeros for that polynomial, and one of my factors would be x minus 5. Verify the remainder theorem. A little curious as to what hint they're going to give us here. Okay. In other words, this does not come out with no remainder. We just evaluated it and we got a remainder of 4. If this divided evenly, we would have a quadratic with no remainder. Okay? How do I do the first one?
It's x plus I, x minus I.
But they don't want that. Write possible quadratic functions. In other words, multiply those two together. What do you get?
X squared.
What's that?
X squared minus I squared.
Which is?
Minus 1.
Nope.
Or plus 1.
Plus 1. It's x squared minus I squared. That's correct, but I squared is minus 1. So it becomes x squared plus 1, which you'll notice only has imaginary roots. Because that's always a positive number. I can't make it equal to 0. Okay, how about B?
X plus 1 plus anything.
It's not x plus anything. It always is x minus something. In other words, when you have the zeros given to you, like they're doing here, or the roots, whatever you want to call them, then your factors are always x minus one root times x minus the other root. So, tell me what that is. In other words, let's write it as factors first, and then we'll worry about multiplying them together. So what is it? X minus what?
X minus 1 minus the square root of 2.
What's this?
X minus 1 plus the square root of 2.
Now, multiply this trinomial by this trinomial to come up with the quadratic.
X squared minus 2x.
That's a tough way to do it. That's rife with possible mistakes. Here's the way you want to do it. We'll multiply that by that. We'll multiply that by that. We'll multiply that by that. You want to take the second term, multiply it by that, multiply it by that, multiply it by that, and then the third term, and then you want to add all 9 things together. If you try taking shortcuts, especially with these kind of numbers, it's asking for error. So what's the next term? I'm going to have 9 terms here.
Minus x plus x to the square root of 2.
Okay.
Plus
let's put the coefficient in front. So there's the first 3 terms. What are the next 3?
minus 1x minus 2 or plus 2 plus 1 minus root 2
Go
minus the root 2x Plus root 2. Minus 2.
Now, let's see. So, we only have one x squared. We got a couple of x's. Actually, we have 3 terms that have x in them. That crosses with that. So now I just got minus 2x. And now let's see, numbers. I got a minus root 2 and a plus root 2. And a plus 1 and a minus 2 giving you that. Unless I made a mistake. Kind of the way I like to do these, let me just show you this. It's fairly useful, I think. So whenever you're simplifying something that's got 9 terms in it like that, let's do it this way. There's my x squared, cross it out. Now I'm going to, first of all, I'm going to cross out everything that cancels, so I can immediately cross that out. Can immediately cross that out. Now how many x's do I have? It looks like I have 2x. Run a line through that, a line through that. The only thing that doesn't have lines running through it is that number and that number. Combine those, you get that. This way I make sure that I did all 9 terms, that I didn't leave any out, by crossing them off as I go. Graph 2 cycles of each function. This is the one time it would really be nice if you had a drawing tablet and I could make you the presenter for a minute and ask you to draw this thing. It's kind of difficult to do so without that capability, but let's give it a shot. What is the phase shift? I'm going to explain to you how to do it, and this is the way you should always do it. Okay? Start with the phase shift. What's the phase shift and in which direction?
Pi over 2 to the left.
Okay, so we're going to go to pi over 2 minus pi over 2. That's where our function is going to start. What is the maximum value that it's going to hit?
There is none.
It's 2.
Or 4.
In other words, cosine curves bounce between 1 and minus 1. But if you multiply them by 2, then they're going to bounce between 2 and minus 2. Okay? There's about 8 ways to do this problem. I'm trying to think of what the best way to show you is. I think, what's the period going to be?
Pi.
No? Remember, your period is 2 pi divided by b. What's b here?
There is none.
B is 1. There is 1. It's a 1 right there. So my period is 2 pi. Okay? And this is really the way I like to solve them. This is my favorite way to solve them, which is start your starting point. If my period is 2 pi, where is my ending point of my first period?
3 pi over 2.
Now the secret is to quarter that up. In other words, I want to find the 4 quarter points. Are you familiar with that term? We've talked about it before, haven't we?
Yeah.
Okay, what are they? What's the halfway point here?
Pi over 2.
That's the first quarter point at 0. Second quarter point at pi over 2. What's the third quarter point?
Pi.
Now we have a reference point to draw our curve. In other words, if I was drawing just cosine of x plus pi over 2, I could now do it. I would start, cosine always starts at its maximum. It goes through the quarter point, the first quarter point, it goes through the x-axis, goes down to its minimum at the next quarter point, comes back through the x-axis at the third quarter point, and finishes at the fourth quarter point. Now all I got to do is connect the dots with a cosine looking curve. Now it's minus 2. If I had a plus 2, then I could label it like this. What's the implications of the minus sign in front?
Switch the graph across the x.
Across the x-axis, exactly. So I'm going to take this graph here and I'm going to do exactly, still going to go through that point. It's now going to hit this point, come back through that point, and finish at its minimum. So it's a reverse, it's a negative cosine curve is what it is. It's a negative cosine curve that's been phase shifted by pi over 2 to the left with an amplitude of 2. But this process of handling the phase shift is key. In other words, figure out your starting point, figure out the period so you can figure out your ending point, and then quarter it up. Always quarter it up. Quartering it up is what allows you to draw the curve. Now, let's take this other one, quite a bit easier. Where am I going to start?
Shift it to the right, pi over 2.
What's the period going to be?
2 pi.
So what's the ending point? Oh, it did say draw 2 cycles of each function. I forgot to do that, but I presume that there's no problem with you figuring out how to draw the second cycle?
Yep.
Okay. What's the ending point for first cycle?
5 pi over 2.
What's the midpoint between those 2 points? And the easy way to do that is to add these two numbers and divide by 2.
3 pi over 2.
What's that quarter point?
Pi.
What's this quarter point?
2 pi.
It's a sine curve. Where do I start?
On pi over 2. 0.
Where's my next point? Where's my next x going to go?
Pi on the 1.
My next x?
The middle.
My next x?
Down below.
And finally back up to there. Again, that's one curve, one cycle only. Now they say draw 2 cycles. Well, I could go in either direction. I could draw another cycle to the right, or I could draw another cycle to the left. I have exactly 2 cycles now. And I know because it's one cycle from there to there and one cycle from there to there. So I have precisely 2 cycles. I kind of like drawing it into negative territory anyway, because that makes me go through the y-axis. If I had just drawn another cycle to the right, it would not have had a y-intercept, which always looks a little strange. Okay, almost done with this, I think.
I think that was the last one.
That is the last one, huh? Is that what you said? That was the last one?
Yeah.
Okay. When's your finals next week?
Yep.
So what do you got a session again tomorrow and Wednesday and Thursday? You're laying it on thick here. I hope it helps. Has your grade been improving
Yep.
since we started doing some of this stuff together? Good.
Yeah.
Good. Okay. I'll talk to you tomorrow, same time, same place.
Okay.
All right, Nicholas. Bye-bye.
Goodbye.